Okay, we need one last idea before we move away from energy. And it's an idea that you've already encountered in your tutorial last week, and that's the idea of system. If I were to get this system started, what you see is that it eventually just slows down and stops. Now imagine if I could get rid of all the friction between the track and the cars and ignore or get rid of any air resistance. In that case, these guys would just keep on going back and forth, back and forth, back and forth forever. And yet the springs are pushing and pulling, sometimes doing positive erg and sometimes doing negative erg. And so, how is that not changing the energy? Well, it's all about system. In general, we've been talking about three different buckets: a kinetic, a gravitational, and a spring potential. And we add those together to get the total mechanical energy. However, some problems don't demand all three buckets. For example, if I were to define my entire system to just be the block, if I draw my red circle around the block, and that's my system, can I talk about the kinetic energy of the block? I can, because the block's part of my system. Can I talk about the gravitational energy? I cannot. Because gravitational energy is an energy that is between this bucket and the earth, pulling on each other. There's not gravitational energy just in the bucket itself. It's in the bucket-earth system trying to get closer to each other. If the earth wasn't there, I could put this above your head and it'd just float there. Okay? So without the earth in my system, I can't talk about this bucket. Likewise, if the spring's not in my system, I certainly can't worry about spring potential energy. That's not part of my system's energy. Now, if I look at just that system, I've got one bucket. And watch what happens to that bucket. When I release the block, when I take the hand away, there's no energy in my kinetic energy bucket. Then it gets started, I get some kinetic energy. Then it's going really fast when it gets to equilibrium. And then it goes past the equilibrium and it starts slowing down. The spring is now pulling back. And then it gets to a turnaround point. And this is what happens that total energy bucket is filling up, emptying out, filling up, emptying out, filling up, emptying out. And that's because the spring is sometimes doing positive erg to put energy in, sometimes doing negative erg to take energy out. And that's a very messy system. For one thing, calculating the erg done by a spring requires calculus. That's ugly. I don't want to do that. So the alternative is to redefine my system such that it includes the spring. Now, if I do that, I can talk about kinetic energy because I've got the block. I can talk about spring energy because I've got the spring. I still can't talk about gravitational energy if I don't put the earth in my system. Okay? Now, watch what happens as it goes back and forth. I release the block. Initially, all the energy is in the compressed spring. And then the spring relaxes a little bit, but now the block is moving. So now some of the energy is in the kinetic bucket. When it gets to equilibrium, the spring is neither stretched nor compressed. All of the energy is in the motion. Then it goes back past equilibrium, the block slows down, and the spring now is stretched. And then it gets to a turnaround point where all the energy is back in the spring. Now watch what happens to the total energy bucket as this block goes back and forth. That's a system I can work with. The energy sloshes back and forth between the two buckets, but the total energy stays constant as long as we have zero friction on that floor, and we usually do. So that's the way I want to define my system. Now, what that suggests is that when I presented you this Verk energy equation and told you that it was the one equation to rule them all and in the darkness bind them, I was lying a little bit. This is what I taught you. That's the truth. Okay? It's only external Verk that can change the energy of a system. If I sit on this table has wheels. If I sit on this table and push on my back, I don't go anywhere. That's one part of the me pushing on another part of the me. It doesn't get me anywhere. I got to push on something outside of the system in order to change my energy. Okay? So, how do we define our system? What do we put inside the big red circle? This is my suggestion. Always include anything in the problem with mass that's moving so that you can consider the kinetic energy in the problem. Secondly, we will always, always, always include the earth in our system. And by that I mean the gravitational force. You should never, I repeat, you should never calculate the Verk done by the gravitational force. You should instead talk about the energy stored in that potential energy bucket. Consider this. If I raise this up, what's your name? If I raise this up above Jake's head, we say it has more energy. It has a greater capacity to do damage to Jake. But that only makes sense if we only count my Verk, right? As I lift this, I'm pushing up while it goes up. I'm doing positive Verk. But at the same time I'm pushing up, the earth is pulling down. The earth is going to be doing just as much negative Verk as I'm doing positive Verk. But I don't include them both. I don't let them cancel each other out. Because the earth is an internal force. That's one part of my system pulling on another part of my system. I'm the external agent that's changing the energy of that system, increasing the energy. Okay? Now, the last thing would be any springs in the problem. Include those in your system so that you can talk about spring potential energy. Again, that means you will never, ever calculate the Verk done by a spring, which is a good thing because that's something that requires calculus. So what are the external agents that do external Verk? No, not them. Is that James Bond to you, or is it one of these guys? Yeah, no, not that guy. No, that guy. Now, you should always leave frictionless ramps and Tarzan swings out of your system. Why? They do no Verk. It's not going to be any trouble to leave them out. Okay? If you leave the floor out of your system, you can calculate the Verk, usually negative Verk, done by the friction force by the floor. The lobster hand can do positive Verk if it's pushing in the same direction as the motion, or it can do negative Verk if it's pushing opposite the motion. We saw that with the rocket sled. And anything else that's not this, this, or this. If you use that system, then the problem will be simple. It will be 2 steps of physics and then algebra.